In this video, we're gonna design the register that we have discussed in the previous video, the parallel input and parallel output register. So the first thing that we're gonna do is create a new Verilog file, and then we're gonna save this as nbit register. So the first thing that we need to have is our module. So we're gonna call module name, and then we're gonna call it nbit register 2. So the input, and then end module. So the input of this register is as what we have discussed here. So we have the input, which is the D, the input of the flip-flop, which is the register, and then we have the clock is an input too, and then we have a load is an input, and then we have a reset, which is an input, and then the only output that we have is the Q, which is the output of the flip-flops. If we go back to our quarters, so we can just name those D, and then we have clock, and then we have load, then we have reset, so we can just say it RST for reset, and the on Q. So the input, and then one thing that we need to do, because this is gonna be a parameterized register, we need to declare a parameter. Just create a parameter, so parameter, and then we can say n, and then we can give value 3. So this is gonna be a 3-bit register, but we can change it if you wanted. And then the input, so input, so we have input, which all of them must are single bit, so clock is single bit, register load is single bit, and then reset is single bit too. And then our input D, this depends on our parameter, so input D. So input D, we can give it as n minus 1, 0. So this it's gonna be a parameterized now, so it depends on the value of n. And then the other thing that we're gonna create here, so we're gonna have a always block, always, begin, end. Now here in this always block, we need to, because this is an event driven, so as we discussed on the previous video, it's synchronous, so we only need our register to be active at the positive edge of the clock. So all the changes must happen at the positive edge. So we can write pos edge. So this pos edge of the clock. So this event driven block will only be active at the rising edge of the clock. And then, so we're gonna have a if statement. So this first if statement, it's for reset. So we need to reset our register, and our register is Q. So this is going to be resetted at we're going to reset it at 0, so we can just say it 1 bit. All the register value will be set to 0, and then we need to declare our output. We need to declare our output, and the output is Q, and then the output, it is reg, since it is in always, and then it's -1 0, and then else if here load. So, and then here we're gonna set our register to be equal to, so we are using a non-block assignment, and then here our register is going to be equal to our input value, which is D. Here we're going to set as D, and then let's save it, and then let's set this as top level entry and try to analyze and synthesize to see if we have done everything correctly. We have some error, and then this is here. Save it again and analyze and synthesize. Now we don't have no errors, so in the next video we're gonna design a test bench file for this register.